So I suppose you may be wondering, what the hell is this channel? What does Deus Ex Machina mean? What's the point of all this content? And it's basically that Deus Ex Machina is the god from the machine, or the character that turns a hopeless situation into a happy ending. And so the content of the channel is supposed to be funny and also enlightening. Um, and no, I'm not God, but Jesus Christ wasn't God either. He was just a quite arrogant guy with a philosophical understanding that he thought was correct, which is why he was crucified, by the way. Um, and however, his philosophical understanding and moral principles had merit, which is why it later took off into religion. Um, so yeah, um, we're at a point in time in which the rigorous pursuit of truth, that is physics, combined with the scientific method, will lead to um, consensus in understanding the nature of the truth. Um, and then we will evolve out of praying, as is already happening with many young folk evolving out of Christianity, um, and so on. Now, who am I? Um, I'm a 24-year-old guy who holds a Bachelor of Science in math and got a double minor in physics and computer science. I did all of this with like a 3.7 out of 4 GPA. Um, and so in math, I proved calculus from 13 properties of numbers, going through limits, derivatives, upper and lower sums, integrals, and then Taylor series. And then I did multivariable calculus theorems in that, like Stokes theorem, Green's theorem, um, surface integrals, linear algebra, Gaussian elimination, eigenvectors and eigenvalues, so on and so forth. Fourier analysis, any mathematical function can be represented as a weighted sum of sinusoidal functions. Um, and so, um, and then, applications in solving the two-dimensional heat equation or wave equation with Fourier analysis techniques, with certain boundary conditions. And then also complex analysis. And so contour integrals, and a slew of other things with complex arithmetic and theorems involving singularities of complex functions, how to do um, um, contour integrals with certain theorems, um, and so on. And then in my physics minor, I did the freshman calculus-based physics course along with classical mechanics, which involved Lagrangian mechanics, which your Lagrangian is your kinetic energy minus your potential energy. And then you take partial derivatives of that to get an Euler-Lagrange equation, which is then you can derive your equation of motion for your system, and then also electrodynamics, Maxwell's equations, um, um, the sort of surface integrals in electrodynamics involving the flux through a surface, um, and then also a divergence and curl of vector fields in terms of electromagnetic fields, or sorry, electric and magnetic fields, and then electromagnetic induction, obviously, Faraday's law, and all the math of all that, and divergence and curl of vector fields, and all the theorems and electrodynamics that involves. Um, and then quantum mechanics, Heisenberg uncertainty, Schrödinger equation in one and 3 dimensions, using ordinary and partial differential equations to solve that stuff. Um, Linear algebra, Bra-Ket notation, integrals involving expectation values of observables, applications of quantum mechanics. In particular, the thing I did was neutron star degeneracy pressure, which is quantum mechanical. And so basically the degeneracy pressure in a neutron star, which if I remember correctly, it leads to its stability. It is fundamentally quantum mechanical, and doing some calculations in that. And so a neutron star is like basically protons and electrons have fused to become just a giant mass of neutrons. And then and so that exists somewhere in the universe. And then physics, electronics. And so I did stuff with like protoboards, circuit elements like inductors, transistors, capacitors, resistors, and then a slew of other things like building resonator circuits, using an oscilloscope and multimeter to measure certain things, and the like, and calculations in electronics involving complex numbers and complex arithmetic. And so if you're not understanding why the heck you need to understand complex numbers, this is actually relevant to physics and quantum mechanics, and also in electrical engineering. So there are a lot of use cases for that branch of mathematics in these areas. And so and then in my computer science minor, I did Python and C coursework, C flag processing, command line programs, manual memory management in C, which is good. So a whole lot of people getting started in computer science will not deal with compiling a language. Python is just, you do not compile it. But then the real computer scientists will know how to deal with compiled languages, in which there's also some level of manually allocating memory for your variables and so on, and propagating that, and dealing with segmentation faults, which is, a slightly lower level than Python. And so C++ and C are compiled languages. And then obviously algorithms and data structures. Can you do stuff with heaps, with linked lists, with priority queues, with arrays, with min heaps, max heaps, developing algorithms involving those data structures. What is the time complexity of maintaining the min or max heap property when adding an element to a heap? All of this, epsilon delta limit proofs in data structures, which are relevant. And then in algorithms, dynamic programming, which is a quite elegant way to develop a recursive function that will basically, in either a top-down or bottom-up fashion, solve a whole host of subproblems until it computes the final answer. And in particular, including memoization, which is a multidimensional array which stores the results of the computed subproblems so that no single subproblem is computed more than once, which enhances the time complexity of the routine. And so I did all that, proving optimality of algorithms as well. And then finally, introduction to AI, which was a course involving approaches like graph search algorithms such as depth and breadth first search, to alpha beta pruning, which is a tree-based approach, adversarial search like Minimax, and so you have in Pac-Man, let's say Pac-Man is a maximizer agent and the ghosts are minimizers, and then you can mathematically and programmatically develop a winning Pac-Man Minimax agent, and then finally reinforcement learning, in particular Q-learning and approximate Q-learning, and so this involved understanding the theory of it mathematically and also developing projects in which you are given this code skeleton and you must fill out the logic of the classes and functions in that code skeleton, which led to a Python Pac-Man reinforcement learning agent that did approximate Q-learning that is sufficiently good given 50 episodes of training to win at least 8 out of 10 games. And so I got like an A- on that, and that was like a senior level, AI course in which some graduate students were also taking that course with a bit more work to do than the undergrads. And that was my undergrad. But further in my physics, I did research in a quantum computing laboratory in which I did instrumentation stuff like getting a particle counter to work for air quality monitoring involving soldering and Python code, designing a zero coefficient of thermal expansion Fabry-Perot interferometer, which is a laser frequency stabilizer or a reference cavity, in which if you want to make a proper quantum computer, your laser frequency needs to be stabilized. And so that reference cavity ensures that. And so I designed that in Autodesk Inventor. And then also doing mode matching calculations in Python on Jupyter Notebooks to match the mode of the laser to the mode of the cavity, and then manifesting that on the optics table with all the mirrors in which you have precise control of the angle of the mirror and so on to actualize your calculated mode matching. And then Pound-Trevor-Hall locking, which is another method of stabilizing the frequency of a laser. And similarly, I worked in another lab for a short time as an undergraduate freshman, in which I was definitely in over my head, in that I was working alongside people who were graduate students pursuing physics PhDs or even postdoctoral researchers, and I hadn't even completed my freshman year of my undergraduate program. However, I was talented, and so I was working on MATLAB code for a micron scale 3D printer, which was doing 2-photon lithography, which is in which 2 photons of laser light harden a photoresist. And that photoresist was on a hexapod, which is an electrical device that can move in 6 degrees of freedom with micron precision. And so then it has a femtosecond or 10 to the minus 15 second laser that is doing this. And so I had successfully contributed, a section to the code which enabled automating stitching prints together in 2 dimensions, or basically creating a 2-dimensional grid of stitched prints with provided step size up on the scale of microns, which is 10 to the minus 6 meters. And this actually worked. And so I lasted around 3 months in that high-profile lab as an undergraduate freshman before getting ousted, which was actually pretty impressive because it was quite intense to actually do anything meaningful at all under high pressure. At that point in my career, as a Padawan of some sort. But anyway, what also resulted from this was that on a walk with the principal investigator of that very lab, I said we should 3D print the ion traps. And so Basically, the two laboratories, the lab with the two photon lithography printing technique and the lab that was doing the laser-based trap-down quantum computing, they collaborated as a result of that idea. And it took about 2 years, but there's a paper on ArcSiv titled Geometries and Fabrication Methods for 3D Printing Ion Traps, in which basically the graduate students in physics and the postdoctoral researchers were the writers. But if you look in the acknowledgement section, you'll see it says, "We would like to acknowledge Aaron Castley, who suggested this collaboration." And at the time, I was that freshman kid in over his head working in both of those labs simultaneously, which is pretty interesting. And so I have this creative imagination that's somewhat on steroids. And so another thing is that I ended up becoming a Ronald D. McNair Scholar. And then my actual publication, in which I was an author, was doing multidisciplinary design optimization for the Portland State Aerospace Society for Launch Vehicle 4, which is a student-built rocket. And so that's my own paper in which I did simulation and optimization to converge on the ideal design vector for the rocket, given both design constraints. So, for example, it is not feasible to make an engine with thrust greater than around 10 kilonewtons for the engineering team. And so that could be a design constraint. And then performance constraints such as the altitude at apogee. What would you like to achieve there? And so it was a pretty interesting project that led to my first publication as a McNair Scholar. Further, some people have it cushy where their parents are paying for their rent or whatever while they're finishing their degree. Well, I worked around 2 to 3 part-time jobs to deal with my own rent and living expenses, renting an apartment proximate to my campus, and so I was tutoring student athletes in technical things. I was also doing the research in the quantum computing laboratory, and as well I was a campus manager with the company Fresh Prince, selling and marketing customized apparel for Greek Life and other student organizations, and actually closed quite a few sales, probably slightly over $20,000 in sales I closed doing that part-time. And then, yeah. And so I graduated around March of 2023. And then some people have it cushy where their parents buy them a car as a graduation present. Well, me also, as an immigrant originally from Jamaica, who only came here when he was 18 years old, right? Well, me on the other hand, I became a citizen, diligently through my own efforts, and bought or effectively leased my own 2024 Tesla Model 3, which I have been keeping to excellent standard, and so paid my own rent to finish my undergraduate degree, and throughout my undergraduate degree, working multiple jobs, became a citizen of my own effort, and got my first car, which is a Tesla. Further, a Tesla has enabled me to give referrals, and so up to 10 people can actually get $2,000 off the price of Cybertruck, Model X, and Model S. And this is also $1,000 off Model 3 or Model Y. And so the options are cash, which is a large payment to own the vehicle, lease, or finance. And so in the lease and finance paradigms, you have an amount due at signing, in which the $1,000 or $2,000 off, depending on the model you'd like, actually is a nice deal. For example, I would have loved a $1,000 discount off the due at signing for my leased 2024 Tesla Model 3. And so I'm going to provide a link to that in the description of the video for people. And I was raised in Anglican Christianity. And then throughout college, being trained in physics, math, and computer science, I evolved out of Christianity. I cohabited with definitely two brilliant atheist guys, one a theoretical physicist and the other one a computer scientist and AI researcher. And so they were on the atheist wavelength, and we were great roommates who did division of labor by just optimizing the machine that was our apartment. And so there was another mathematician as well. And so every 4 days, each one of us cooked a meal for the entire household, such that each one of us would have 3 free nights. And so we lived in harmony, just with sound mathematical optimized agreements for how to do division of labor for a place of abode. And so, and none of us prayed at all. And so that theoretical physicist got into a Harvard theoretical physics PhD program. That computer scientist got into a University of Texas at Austin computer science program. And then I got into the Northwestern electrical engineering master's program. In my case, as a McNair scholar, and so on. And so I haven't prayed to anything at all in over 3 years. And the truth is the following. Praying is not interfacing with any God. Praying is purely an evolved, goal-oriented behavior in which you are only interfacing with your own conscience and what you think should happen, given your own ideals of what is right, what is locally prosperous, and what you want. And then along with the moral structure of some religion. And so I've met, let's say, a Christian named Dante who said, the things I pray for, they really do become manifest. And this is true. However, when a prayer becomes manifest, it is not because any God has heard that. It is simply because you will have clarity and focus on what you want. You've prayed about it, and then you take outward action to manifest it, which may or may not lead to its realization. And if it is realized, then that person's brain will have a confirmation bias and then think that some God must have heard them. And that cycle perpetuates, in which the delusion it becomes quite ingrained in consciousness. The truth is highly ironic, but this is correct. Yeah. And so that's the thing. And so I'm not, however, an atheist. And so if you study physics, if you study physics, you'll understand conservation laws. And so there's conservation of angular momentum. And so a long time ago, when the sun had just formed, there was a protoplanetary disk, which was just gas and dust, that had non-uniform density. And so the gas and dust nearer to the sun is going faster than further away. And so when a dense section of that protoplanetary disk collapses, there is actually net angular momentum towards the east. And so the planet, on its collapse, must continue spinning towards the east, which is why effectively the sun only illuminates half of the earth, and any human on the earth will perceive the sun rising in the east, directly overhead at midday, and setting in the west. And you can imagine just all humans on the earth going towards the east along with the surface. And basically, it becomes night once you cross over that section that's the line that is defined by the hemisphere that is illuminated by the sun. And then you'll see the sun go below the horizon towards the west. But conservation of angular momentum also applies to the bodies of the puny humans on the planet. It could be a figure skater, or it could even be a stripper. Fundamentally, the angular momentum vector L is defined as the moment of inertia of the body multiplied by the angular velocity vector of the body. And so when that figure skater has her mass dispersed from the center of rotation, which is her skate that's on the ice, and is spinning, but then constricts her mass towards the center of her body, effectively that moment of inertia of the body decreases, but L must stay constant, and therefore she must spin faster, which is why the angular velocity increases. And then even a stripper doing a pole dance, the same effect occurs. And then the conservation of energy is an even deeper one, where basically the sun is putting together 4 hydrogen atoms into 2 deuterium isotopes into a single helium, and that helium is less massive than the 4 hydrogen that goes into it. And so then energy is released, which is actually proportional to the mass defect. And then that energy, reaches the earth in the form of heat and light. And so the energy on the planet Earth is fundamentally due to the sun. And so basically, solar panels or photovoltaic cells, basically the photons are going to excite a component of the electronics to a different potential than the other component, and that will generate electricity in the form of flowing current, right? And then even the wind, well, the wind is caused by 1, the continuing rotation of the Earth towards the east, and then 2, the temperature gradients. And so the equator is quite hot because the intensity of radiation decays as the square of the distance. And so the equator is hot, the poles are cold, and then fluid flow is always hot to cold. And then water happens to have a very high specific heat capacity. What that means is that it takes a lot of energy for the temperature of water to increase. And so basically during the days the land will be hot, the oceans will be colder, and then there will be a land to sea fluid flow. And so all the fluid flow patterns on the earth are a form of kinetic energy that is due to the sun's energy impinging on the earth fundamentally. And so then humans can prop up things called wind turbines, which are pretty much the inverse of a fan, right? Because a fan is electricity going into an electric motor, and then spinning the fan, and then a wind turbine is the kinetic energy that is the air spinning the blades of the wind turbine, which then effectively causes a rate of change of magnetic flux in the dynamo, right? Because an electric motor is the inverse of a dynamo. It's the same physical mechanism pretty much. It's just that one is taking electricity and causing motion, the other one is taking motion and producing electricity. Um, and and then that wind turbine is generating electrical energy. And so these conservation laws that are unbreakable, in my mind, indicate that there is a God, there is some level of intelligent design, because it would be ridiculous if all those mathematically precise laws that are replete throughout the creation and held rigorously to would just be, a godless mess. In my mind, this indicates that there is a God, there is intelligent design, and that's why these laws are held within the universe. But I don't think in any fashion that intelligent design or that God is good. It is not at all good. And so the complexity of that is, I'm a deist. So there's probably God, there's probably intelligent design. Humans create notions of that thing being benevolent in relation to justifying themselves and what they want, and praying for what they want, and then going around having confirmation bias and thinking that they're blessed, when meanwhile there's external suffering, which is not allowed by anything benevolent. And so, for example, in America, the debt is quite high. It's so prosperous that it's wasting 40% of its food. And then people want more, and they want to travel around the place and experience more. Then there's some Mexican guy living in some simple dwelling, near the Mexico-America border, who's wishing for a better life in America and crying himself to sleep every night. And then that fellow just dies. And meanwhile, the American who is a born citizen with a passport can travel to Cancun, Mexico for a great time and then go back to their prosperous America. And so there's no Jesus, there's no God, there's nothing good at all that's allowing the two sides of the coin, so to speak, to coexist. It is simply God delusion, hubris, and confirmation bias. And in a universe with intelligent design, yes, probably God, yes, but that thing not being benevolent on the scale of human life outcomes and human experience. So yeah. And so I'm pretty much right about everything, which is why I have the Deus Ex Machina channel. And this is actually all the truth, which is why I'm speaking to this microphone on my phone device right now that's recording the information, because the sound waves are making a magnet vibrate in such a fashion that the information is being transcribed into electrical information. So because the vibrating magnet induces a change in the electric field that transcribes the information electronically as I speak. But anyway, so and so I have some videos on the channel saying to use aspiration, and then I also have this video titled 13 Cars. And so basically I've been using aspiration since June of 2021, and actually at the present time there's now over 500 trees planted in Kenya and Haiti. And so instead of 13 cars, there's now 50 cars whose emissions are effectively nullified for around a year, with the sequestering power of that amount of trees. And so Kenyans and Haitians have been employed to do this. Biodiversity has been enhanced with a whole bunch of mangroves with birds flocking to them. And then you're adding sequestering agents to the environment to help with climate. And so, yes, you could imagine effectively, as a single aspiration user who's been using it since June 2021, who's 24 years old, there is effectively 50 cars off the road for a year with my impact only. And the cost to plant a single tree is usually on the order of a few American cents. And so it's not something to gloat about in terms of it being expensive. It's precisely because it's an elegant mechanism to cheaply, over time, make a significant contribution to climate. You won't even notice it building up, but it builds up really quickly and for minimal cost. So I encourage you to check out Aspiration. So yeah. So yeah. And so there are people who think that climate change is a hoax, but it's not. So basically, the physics of putting carbon and other things into the atmosphere is such that the radiation that's normally lost to space is reflected back towards the Earth, and so that causes the greenhouse effect. And so you're seeing record temperatures across the globe. You're seeing heat waves that are killing people. You're seeing flooding in Dubai. Well, how is climate change related to flooding? Well, if it's hotter over the oceans, it's more likely for certain powerful storms to develop, which then can cause the historic levels of flooding that we're seeing even recently in Dubai. And so this is all connected. And so some people are like, oh, well, climate's been oscillating up and down for so long. But no, you can actually isolate the greenhouse effect, and you can understand that yes, humans putting these greenhouse gases into the atmosphere causes that thing, and the radiation is reflected back towards the Earth instead of lost to space as it normally would have been without human caused emissions. So this is just true. Yeah. And so on. So this is all correct and ironically correct. The atheists are wrong. The Christians are wrong. The people that pray are wrong. The actual truth is that there's God, there's intelligent design, but it is not benevolent or good on the scale of individual human life outcomes. So, yeah. So, yeah. So, yeah. So, other reasons why I'm Deus Ex Machina. So, evolutionarily, back in days of hunter-gatherer, so the female gatherers would select for the strong male hunters. And if you were not a strong male hunter who could bring in a good amount of meat for the family, the females would not select for you. And so if you time evolve to the present thing, where agricultural technology is such that majority of intelligent men are not directly involved with food production or hunting, right? But they're lawyers, they're engineers, they're computer scientists, they're doing intellectual things. And still now, a female will select for a man who can stand up on his own feet and has some, sort of place in or role in civilization such that he is stable and can provide a living for himself and the woman. So the same thing is happening just at a more abstract intellectual level now, in terms of masculine strength being ideal or selected for by women. Yeah. Um, Other things, other true things. I've done this survey now. Um, Size does not matter. So for all the guys out there worrying about size, I was talking to this girl, and she said that one time she had actually had sex with a fellow who was 7'2", who, uh, when fully erect, was around 11 inches, right? Um, and it was an experience, right? But her current boyfriend is actually average, or if I remember correctly, she said slightly below average. Um, and so there's this common misconception that size matters. Um, it really doesn't. Why? What is the structure of the female vagina? Um, the clitoris and the G spot are not very deep in the vagina. Um, and so if you actually understand this, um, in a lot of ways, a whole lot of females will prefer, you know, something that's not that large, because the sex is more comfortable, and all that excess is not necessary. Um, so this is for males wanting true information. Size doesn't matter. End of. So, and then so so there is a small subset of females called size queens who do uh, have a thing for more endowed men. Why? Because although the clitoris and the G spot are not that far in the vagina, um, um, when a vagina becomes aroused and lengthens, um, the cervix could be considered the C spot, and near cervical areas can also bring some amount of pleasure. Um, and so, with more endowed guys, there's an additional layer of cervix or near cervical stimulation that could lead to levels of more intense orgasm, like uh, their whole body uncontrollably shaking, or levels of or combination of that with some amount of squirting, um, that's another layer to it. Um, but the vast majority of females on planet Earth are not those size queens. Um, so, um, so yeah, yeah. So, um, and so a whole lot of attributes of males are more desirable. And yes, I'm a physicist who knows pretty much almost everything, and so you may think that some of what I've just said is grotesque, but it's just absolutely true. So, so anyway, yeah. Um, yeah. Anyway, so yeah. Um, yeah. And then also more Deus Ex Machina, Tesla, um, autopilot or full self-driving is statistically safer than human, um, in terms of collision probability. And so basically, a human is a biological neural network with eyes and the prefrontal cortex, um, um, being a neural network that is making predictions. Basically, you have a vector space, which is defined by the basis vectors of brake, accelerate, turn left, turn right. And so the human biological neural net, given the eye input, is operating on that vector space um, in the ideal fashion to deal with the natural world. Now, the Tesla Full Self-Driving is using the Tesla Full Self-Driving computer, whose hardware has been optimized to run neural networks. And so it's currently running an end-to-end neural net that has been trained on a whole bunch of fleet video data. And basically, given the real-time data from the 6 external cameras, is spitting out the weights for the vector space. And so basically, okay, what is the vector space? Acceleration, braking, turning left, and turning right. How severely should those 4 actions be performed at any given point in time? Well, the convolutional neural net is going to spit out the weights, which indicate how severely those actions should be performed at a given moment in time for the information perceived by the 6 external cameras. And so with that mechanism, I've experienced all my drives, even like 2-hour long city to city drives without intervention. And I've seen the car do things that were, better than if I was in control. So yeah, you can kind of simulate and understand everything in the universe, even that. And so, yeah. So that's me. That's all I've done. This is all true things. You could start a religion that believes the following. We should understand the rigorous pursuit of truth that is physics, believe in the scientific method of testing hypotheses and peer-reviewed literature, and understand that there's probably intelligent design, but you cannot pray to that thing and interface with it, and it is not benevolent on the scale of individual human life outcomes. Use aspiration. Techno-utopia is within reach. There's a how to make utopia video on the channel, which is the first video. And this is overall an explainer video for what the fuck this Deus Ex Machina channel is all about. Thank you, and subscribe. Check out the link in the description for a significant discount on a new Tesla if you so desire.